So I fitted this hopper. Has this wear plate in here, a bit of a wear plate in here which you can take in and out, so that's easy to print. I might see about replacing this with some sort of cutter. There's a bit of a gap there. Let's get going, and I've done with it. I'll talk a little bit more about this at the end of this video. Watch out for your ears here, because this is loud. This is guitar. So as you've seen, there's thrown pieces out, and that last one was really vicious. You know, got really yank on my hand there. So I'm going to use a small wrench. Let me grab this bit. So throwing bits in this hopper, just not really very good. Obviously you want safety glasses on when you're doing this. So I've got this held in a small wrench. Now bits like this are far too big to even go in the hopper, generally speaking. I might be able to get the corner there in the hopper. So bits are too big with the hopper, and it's seen it there, just throw the piece out when it's lightweight and that. And generally plastic parts are lightweight, especially with not much infill. To a large extent I think this hopper makes it worse, because although it does contain some of the bits that fly out here, you might see them on the, getting caught on the side there, so it's really impossible to get in at the blades with a biggish bit like this unless I cut this bit down with, say, a saw or something. I mean, obviously it is sort of cutting there, the cutting blades. We find a narrower piece that's, and you can see it's kicking there. It's kicking like the bits back when I've got most of the blade exposed at the top edge here, as opposed to having a cutting block, what I call a cutting block, which went across here, which although it cuts down the area, seemed a lot more contained, a lot more safer. I'll just I think I said this on the back end of this, that when I took this apart to fit this like a bit narrower piece here, because it was rubbing against here, is that I noticed that this bolt, a wing nut sort of bolt, there's a big wing nut in here that spreads the load about, had come loose in the chuck, and I don't know why. This has 3 slots in this bolt so that the teeth of the chuck, 3-jaw chuck will grip it. But it's almost like this bolt inside here had come loose. It wasn't tight, even though I tightened this down. Right, let me have a look for some bit more plastic. I should have some, I think. So here's a plastic bolt I was experimenting with. Now I've got this metal bolt in here which has a key seat in it, and there's a key in here, and that key goes in the keyway of the cutting discs which I talk about here. So I'd like to thank the manufacturer who made put the key seat in this M22 by 150mm bolt. Right, well, this was like testing plastic ones. I think this is very light. This feels very light, so not much infill in this, but this should fit in there, and we'll see how it goes. So you can see the amount of infill there, very lightweight. It was only a test piece. What I found is printing out these balls that had to be maybe about 18mm diameter, well 18, 19, no more than 20mm diameter to fit in a M22 nut. Right, let's see, here's one I did earlier which has a key seat in it. Experimentation. This is heavier, I can feel it's heavier, but basically the same size. Let's go for this. As you can see there, it's jammed. Did you hear that? Well, you mightn't see so much, but jammed. This drill has no reverse on it, so can I turn this by hand? No. Well, what am I going to do now? I think it's better, to be honest with you, to go back to having this like a cutting block on here, which like cuts off half the blades and it gives a 90-degree sort of cut then. See, this is jammed in the edge here. As I say, if I had a cutting like blade on here, it might be better. That is well and truly jammed in there. Let me get it unplugged for safety. Okay, that's unplugged for safety. I'm trying to, I cannot turn this. Oh yeah, only just had to use quite a bit of force there to turn that like backwards, and it has certainly chewed up this cutting, well, almost what I'm calling a wear plate, deliberately put on here to wear down. Well, not deliberately wear down, but this will wear down quicker than, but this will be easier to print out if it does wear down, because this has been ripped to bits. So I'll show you that. So that bit it's got jammed in this gap here. Possibly the gap is a bit too wide, but then again, I think I might go back to using the cutting block I had on. Let me try this again from, well, I'll just try it again, a different angle or what have you. Oops. Let's get plug back in, unplug that. Right. This is what I've noticed with more blades exposed like this, it's what I would term as seems a lot more vicious, a lot more willing to bite into the part, just totally rips it to bits or seems to, as opposed to having a cutting block which sort of chops off, well, restricts the area of the cutting blade quite a lot by about 50% there. Well, can you see what's happened there? So here is the wing nut, and this part here, let's have a look at that part. It's split right in two, not along where the wing nut goes. So there's one part. This is not 100% infill. I would have expected it to go across here, because that would be like the weakness. There's a flat bits of this wing nut sort of go in this groove here, and the hex bolt goes in there, and it's just split in half. I think the infill there is about 35%, so it's not like got the major strength. Well, that's not working very well, is it? So I'll probably go back to this cutting block. Right, I'll show you the ball. So as I say, that's just shattered. So again, we've got a few like bigger bits, those are of that bolt, plastic bolt I tried to do, but the other parts are pretty granular.